Welcome back to this year's BYK Live Event. There's so many people tuning in from all around the globe, almost 100 countries. We appreciate every single one of you. Thanks for being with us and using the Q&A function and everything. It's really, really great to be in an interaction with you guys out there. I hope you could use that little break to open the windows and, most importantly, refill your cups with some water, because this is a perfect transmission for me. We have a lecture now which is all about water-based products. What once has been a trend nowadays is of highest importance. BYK has developed quite interesting solutions in this field, and I'm very happy to introduce you to Markus Vogel, who is Head of Global Enduse Decorative Coatings, Steffen Romanski, Head of Global Enduse Wood Coatings, and Lara Walter, Head of Technical Service, Marine and Protective Coatings, who will now show you every detail about all of this. The next lecture is called Turn Water-Based Challenges into Opportunities with Labeling-Free Dispersing Additives for Binder-Free Grinds, Next Generation Silicone Defoamer, and New Defoamer for High-Build Water-Based Systems. Enjoy, and welcome on stage, Markus. Stage is yours.
Thank you, Mark, for the nice introduction. Again, it's a pleasure to work with you. Also from my side, a very warm welcome to the second session of our BYK Live event today with the title Get Inspired by Water-Based Innovations. So here we have the focus on wetting and dispersing additives, as well as on two new defoamers. I want to start with a statement. Solvent-based coatings have always been the best. Yes, these are established systems. Everybody has experiences with solvent-based formulations. They show a very good performance. Endless number of raw materials are available. You have a broad range of solvents, a broad range of polarities available, but times are changing. Years ago already, it started to switch from solvent-based to water-based formulations. So water-based coatings are already the future. In some application areas, they already dominate the market, for example, in architectural coatings. More than 90% or 95% in some regions is already water-based, but also in other market segments like protective coatings, industrial coatings, automotive coatings, they have already a significant market share. And the growing rate of water-based coatings is much higher than for solvent-based systems. What are the reasons for the switch from solvent-based to water-based? For sure, one big reason are all the regulations. Here you see just some examples of regulations. Eco-labels, the European eco-labeling, the Blue Angel, the Green Seal, company internal regulations, or also governmental regulations. And all of them are dealing mainly or partially with VOC reduction. And the solution is water-based formulations to make formulations more healthier, to reduce hazardous substances, and to develop more environmentally friendly coatings. So at least a contribution to less harmful, healthier, and also to sustainable coating formulations, which is a really trend in the industry. But the change from water-based to solvent-based, to water-based formulations is often quite difficult, because now we are talking about just one solvent, water, with a certain polarity and with a very high surface tension. So new binders were developed for water-based formulations, and with that also new additives were needed to achieve the same good performance which you know from solvent-based coatings, or better performance than solvent-based formulations. And we at BYK like challenges. We have already a broad portfolio for water-based formulations, wetting and dispersing additives, surface additives, defoamers. And the majority of new projects, of new products, is mainly for water-based formulations. So with our innovative additives, we want to support your daily work. We want to simplify your developments. We want to make your life easier in the lab. We want to improve the formulations. we want to be a partner for you for the new developments to achieve the highest aesthetic demands combined with the best protection properties also in water-based formulations. Now coming to the first products of this session. Labeling-free wetting and dispersing additives for binder-free grinds, but not just for binder-free grinds or binder-free pigment concentrates, also for co-grinds. And here we start. Why are wetting and dispersing additives so essential? You see it here in this small video. Pigments and water, they don't like each other. They cannot be wetted just by water. But adding just a droplet of wetting and dispersing additive, you see an immediate wetting of the particles. And this is the first and very important step in the dispersion process, wetting of particles, replacing air by a liquid. In the second step, then, you grind down the agglomerates to smaller agglomerates, in an ideal case, to primary particles, to get the highest color strength. There's a direct correlation between particle size and color strength. But at the end, the pigment particles have still a high affinity to each other, so they have to be stabilized. And this is also the job of the wetting and dispersing additive. Stabilizing by steric stabilization, electrostatic stabilization, or the combination of both, the so-called electrosteric stabilization, to achieve at the end the highest color strength and the best long-term stabilization of the pigments in your formulation, in your water-based pigment concentrate, or in the base paint. But also technologies changed over time. In former times, mainly binder-containing pigment concentrates were produced or developed. For this, we had BYK 2012, a very good additive for binder-containing pigment concentrates. But technology changed to binder-free pigment concentrates, so just water and pigments. And here you need new additives. And for this reason, we developed in the past BYK 2015. This could take over the job also from the binder. And now you have more freedom with the pigment concentrate. The pigment concentrates with our binder show a broader compatibility to different systems. But you see also here on this slide again already, this BYK 2015. Labeling HC17 comes from the biocide package in the additive. And therefore, the further development was this BYK 2015 BF. BF stands very simple for biocide free. So now, a wetting and dispersing additive, labeling free, especially for a broad range of organic pigments, and especially for wood coating formulations. It is a solution of a structured acrylate copolymer with pigment affinic groups. It's VOC-free and, as mentioned, biocide-free. And I show you now two examples. Here, first example, organic pigment, organic red, PR122. We prepared a pigment concentrate with 30% pigment loading and 25% solid on pigment of this BYK 2015 BF. And then we added this pigment concentrate to a white base paint, to a high gloss acrylic emulsion paint for wood coating applications. And you see the nice color strength development and the very low delta E value. So this BYK 2015 BF shows a very good compatibility to this system. But for wood coatings, transparency is very important. And here you see the second example. With organic green, with halogen green pigment, we prepared the pigment concentrate and added it to a clear acrylic wood coating formulation. And most important, and you see it here, the very high transparency, the high clearness, and the nice color in the base paint. But what about other additives, other pigments? Inorganic pigments, transparent iron oxides, or even carbon blacks. Here we saw some limitations with this BYK 2015 BF. And therefore, now we come to our latest developments for wetting and dispersing additives. This BYK 2018 and this BYK 2019. For binder-free grinds and for co-grinds. You see it already here on this slide, labeling free. But what is behind? We have one basic structure for both additives. We have a hydrophobic backbone, and then hydrophilic side chains. You need in water-based formulation these hydrophilic side chains for the stabilization, for the steric stabilization of the pigments. The side chain has to be soluble in water, compatible with water. But on the other hand, you need a high affinity to different pigments. And therefore, we have groups with a high affinity to inorganic pigments. But in this molecule, we have something more. We have also in the structure pigment affinity groups for organic pigments, which makes this structure very universal for all kinds of pigments. By the way, this molecule or these additives are produced according to the so-called CPT, to the controlled polymerization technology, which gives a very defined molecular weight and narrow molecular weight distribution, which then gives also a better performance. Coming to some benefits, some key figures of Disperbuc 2018 and 2019. When you use it in pigment concentrates, you will achieve a strong viscosity reduction. For you, it means you can achieve high pigment loadings with a Newtonian flow behavior. When you add these pigment concentrates then to your base paint, you achieve highest color strengths with organic pigments and transparent iron oxides, excellent transparency combined with high gloss and low haze values. The Disperbuc 2018 you can even use at very high pH values, thinking about silicate paints or water-based epoxies. And it shows really a broad compatibility over a large number of binder systems. And as mentioned, you can use it really for a broad range of pigments, not just reduced to inorganic or organic pigments, even transparent iron oxides or carbon blacks. Coming to some results with Disperbuc 2018. Here you see a short video about the viscosity reduction, again with an organic red pigment. In this case, Hosterpan Pink E. Yeah, very nice flow behavior of the pigment concentrate at a pigment loading of 30%. This was directly after production. But you see here in the graph, the yellow line is Disperbuc 2018. Also after storage, where some other additives failed. So at the beginning, 2 additives in this graph were very good, but after the storage, they differentiate. Just Disperbuc 2018 gave also after storage the good performance, the low Newtonian flow behavior. Another example about the efficiency of Disperbuc 2018 and its excellent stabilization and rub-out performance at very low additive levels. First, you see here organic green, again halogen green L8730 in the pigment concentrate. Then we add this pigment concentrate in acrylic dispersion-based paint. 30% additive solid on pigment. You see nice delta E value, high color strength development. We set this as 100%. And then we reduced the additive dosage down to 15% solid on pigment. And you see directly we lose color strengths and we achieve just very high delta E values. So the additive is not efficient anymore at this low dosage. But with Disperbuc 2018 now, you see at the same low dosage, we achieved the same good high color strengths as with 30% solid on pigment of the standard wetting and dispersing additive. And again, a very good compatibility in the base paint expressed by very low delta E values. So it is more efficient and sometimes less is more. I come later to this. Transparent iron oxide, the next example. First of all, iron oxide yellow. You see here with iron oxide yellow in a wood coating formulation, the really high clearness, the good transparency, the brilliance of the paint formulation just after production of the pigment concentrate and then added to the base paint, but also after storage. And sometimes you see it here much better. After storage, this could be the problem. On the right-hand side pictures, you see that after the storage, the haze value is increased and the transparency is decreased. Means the long-term stability is not given with the market standard. With Disperbuc 2018, over a long time, you achieve the same good performance. Co-grinds. Now we are coming to marine protective. Here, an example, water-based epoxy primer. We use titanium dioxide and fillers, and we add 1.5% active on the fillers and pigments. And here, with a standard, first you see something is going wrong there. There is a loss of coating properties, especially delamination occurs. And with Disperbuc 2018 and 2019, It's really minimized. We achieved this by a very good balance between the hydrophobic backbone on one hand and the hydrophilic side chains, which you need for the stabilization of the pigments. But because of the good balance between these two, let's say, chemical chains, we minimize the side effect of corrosion. Means also in this case, a more efficient additive can lead to better coating properties because you use less of them. And then additive like Dispersive 2018, 2019 minimize these side effects again. So you achieve high resistance and good corrosion protection in your formulation. Another example, industrial coatings. Here we see a 2-pack PU coating for industrial application, mixed pigmentation, yellow pigment, green pigment, again an inorganic yellow pigment, and titanium dioxide. And after storage of 2 weeks at 40 degrees, we applied the paint. And you see the lower delta E value with Dispersive 2019. Just a delta E value of 0.24, which is very, very good, combined with a high gloss and good color strength development. So it means both additives are very universal in use. Co-grinds, pigment concentrates. Coming now to the overview. When you are looking for a specialist just for inorganic pigments, then we see that in some cases this BYK 2019 is a little bit better. So for titanium dioxide and inorganic pigments, first choice should be this BYK 2019. When you are looking for a more universal wetting and dispersing additive, and you want to grind any kind of pigment, transparent iron oxides, organic pigments, or even carbon blacks, then the first choice is this BYK 2018. It covers really the whole range of pigments. And you see it here. We tested it in all of our end users. And we achieved always good results in architectural coatings, in water-based binder-free pigment concentrates, as well as in silicate paints. It is very stable also at high pH values. We achieved excellent results in graphic art applications. In wood and furniture coatings, excellent transparency, which is very important. You want to see the nice structure of the wood. So for organic pigments and transparent iron oxides, excellent solution. In automotive coatings, we achieved excellent results in the slurry production. I showed you the example of a general industrial coating formulation. Remember the 2-pack PU, the green one, with high color strength development, high gloss levels, and low delta E values. Protective coatings, remember the water-based epoxy primer with minimized side effects, so better corrosion protection for your marine and protective formulations. In floor coatings, water-based epoxies, 2-pack water-based epoxies, you grind usually in the amine part, so again at higher pH values. Yeah? And also here we find excellent results and a good storage stability. And last but not least, even in adhesives and sealants to grind your filler particles in the formulation, again, very good results. And now remember the side effects of additives and water-based formulations, the high surface tension. And usually you have to use surfactants to reduce the surface tension. And one negative side effect could be form stabilization. And this is now the topic of the next presentation. And with saying that, I want to forward now to Steffen.
Yeah, thank you very much, Markus, for your nice presentation and also for the teaser to my presentation. Before I start with my topic, I would like to say hello. So good morning, good afternoon, and good evening, ladies and gentlemen in front of the screens. My name is Steffen Romanski, and I'm going to continue our journey through up-to-date additives for modern water-based formulations. And as Markus already said, so water-based formulations clearly have their advantages when it comes to sustainability, but to achieve comparable wetting and other properties to solvent-based coatings, they do need additivation. And some of these so-called surface additives have negative side effects like foam stabilization. As you know, foam can have severe consequences, either during production and also during the application process. In the production, foam limits the amount of material you can fill into your reaction vessels. And also during the application, of course, it's even worse because you have longer waiting times, and if the foam stays in the coating during the drying process, you have severe visual defects and also limited protective properties of your coatings. Because of that, the use of defoamers is really recommended to achieve the best from your formulations, to get bubble-free and flawless coatings. Over the last decades, a couple of different defoamers have been developed, like mineral oil defoamers, polymeric defoamers, but also silicone-based defoamers. Silicone defoamers have unique properties, and one thing is they can be tailored to the paint system by varying their chemical structure. Most of these old silicone defoamers are actually tailor-made for mature paint systems, and because of that, in modern paint systems with lower amounts of cold solvents, they have high incompatibilities, which can lead to negative side effects like, for example, haze, like cratering, bad leveling, and because of that, it is time for something new. So we developed a new class of defoamers, and one of the examples for these defoamers is BYK 092. They are tailored for up-to-date paint systems, and because of that, they really fit into the systems with low cold solvent amount. They can easily be incorporated into the paint system and have outstanding clarity and transparency. Last but not least, they still maintain high efficiency, which makes them very, very valuable for you to achieve the best for your formulation. I would like to start with a short summary of the BYK 092. So it has excellent defoaming in several systems, and I will show you examples for clear coatings, matted coatings, and even pigmented systems. It has no or minor influence on haze and cratering, and also it's suitable for different application methods, and especially for industrial wood coatings, which is my area of responsibility. It is important that you can use it in roller coaters or also in automatic spraying. But you can also use it for application by brush or roller manually. Yeah, it's of course always very easy to make such bold statements, and now I would like to show you some experimental results from our laboratories to really highlight why I'm saying that. The first test that we're doing is the so-called pour-out test. In this test, actually, we used matted furniture coating system based on an acrylic binder. And the first thing you do is you use a dispermat to steer air into the coating, more or less. So it's always the same time and the same shear force that you introduce the air with. And once the steering is stopped, the coating is immediately poured out onto a black PMMA plate. And after that, you let the coating stand for about 1 minute, and then you do the first visual examination. So if you just wait the minute and then you take a look, on the left-hand side, we have our competitor 2, which is a market standard, and there you see that it has a lot of foam left, so maybe it's a bit too compatible. In the middle, we have the BYK 092, which has no foam left and really a flawless surface, so really nice result. While on the right-hand side, the defoamer is really active, so you can see no foam, but you see some surface defects, so maybe it is a bit too incompatible. Then we take the same PMMA plate, let it dry for about 12 hours, and afterwards we do the visual examination again. So on the left-hand side, you can see the foam is really incorporated into the surface during the drying process, so no air can leave the system. In the middle, the BYK 092 has a really nice surface, a very good result, while on the right-hand side you can see that the surface defects that you've already seen in the wet film still maintain in the dried film, so also not an ideal solution, while BYK 092 is really giving you very good properties. A very important factor for defoamers is really their incorporation. And to show that, we used actually a clear coat system, so we can not only look at the defoaming properties, but also on gloss and haze. And we poured it on a transparent PE foil instead of a black PMMA plate. So then we checked different incorporation conditions. And under so-called very mild conditions, you can see, for example, here, 1 minute at 2 meters per second. The competitor product is really giving a lot of incompatibility. You can see cratering, and that is quite normal. So that's not very severe. But the BYK 092 actually is already a lot better. Still not perfect, so I wouldn't recommend to use these conditions for the incorporation, but it gives you a first hint that it's really compatible to the system. When you use medium incorporation conditions, like 10 minutes at about 4 meters per second, you can see that both our market standard and the BYK 092 have a really nice surface. There's no foam, there's no cratering, but when you have a closer look, you can see that the BYK 092 has very nice transparency and no haze, while there is clearly some haze in the competitor product. So that is really nice for clear coats, and the BYK 092 is outstanding here. When you do very harsh conditions for the incorporation, you can over-emulsify your defoamers, so it loses efficiency again. At 30 minutes, at 6 meters per second, for example, the BYK 092 still gives you good results and a nice surface, while you see the first surface defects again in the competitor product. So you have a very broad compatibility to different incorporation methods when you use the BYK 092, which is clearly another advantage. Now I would like to show you some tests that have been done in our architectural coatings lab, and they also used a high-gloss transparent coating based on an acrylic binder. The foam was rated with grades from 1, which is perfect, no foam, to 5, a lot of foam. And as you can see, without defoamer, there is a lot of foam, while with the market standard and the BYK 092, both products show nice defoaming. So yeah, if not, it wouldn't be a market standard, right? But when you look at the gloss and the haze of the coating, you can clearly see differences. So always the control without the defoamer is the best, and the BYK 092 has a very, very minor influence, while the influence of the market standard is a lot higher. So as in our wood coating systems, also in the architectural coating system, the BYK 092 shows outstanding transparency and really no haze. You can also use this same coating actually and do what we did in our wood coatings lab and pour it on a PE foil on a transparent one and take a photo. This one here is the control without defoamer, and you can see, yes, it is clear, but of course there's a lot of foam. While if you have 0.3% of BYK 092 in your formulation, you get a flawless surface, no haze, perfect transparency, and you can clearly see our nice BYK logo here behind our PE foil. The last system I would like to talk about is actually an emulsion paint system with a lot of pigment loading. So the system that is quite different from the ones that we've shown before. And on the left-hand side, you can see the control without defoamer. On the right-hand side, the BYK 092. So as I think this picture is not self-explaining, I would like to explain you what we did. So we actually took a foam roller or multi-print roller and rolled the coating on a contrast chart, and afterwards we took a microscopic image to really see the differences more pronounced. And on the left-hand side, I think this would also be visible without a microscope. You see a lot of foams, microscopic foam, but also a bit more macroscopic, bigger images, while on the right-hand side, you only see some minor and very small foam bubbles left. So the defoaming is a lot better. But under the microscope also you see, yeah, it's not no foam at all. So it's a very nice defoamer for the system still. Now, after all those experimental results, I would like to start my summary again. And the first thing I think is we have seen that the BYK 092 gives excellent defoaming in several systems, be it pigmented, matted, or especially, of course, clear coating systems. It has high clarity there, no haze, and also it has no or very, very minor influence on the cratering, and it is excellent for various applications, for example, conventional spraying, application by roller, or even by brush. Last but not least, actually, I would like to draw the line to our first presentation of today, to the regulatory part. Because in all of our new developments, we really take a focus on regulatory. So also the BYK 092 is VOC-free. It has a very, very low cyclic silicone content. Philip talked about that in the first presentation. It is compliant to several food contact regulations. Actually, also Philip talked about our nice guide on the web page. So you see everything belongs together here. With that, actually, I would like to show that BYK 092 is highly recommended for wood and furniture coatings and also for architectural coatings. That's why these two end users were very prominent in my presentation. But it's also suitable actually for floor coatings, printing inks, or adhesives and sealants. I think especially due to the food contact properties. Now I would like to hand over to my colleague Lara, who will give you some very nice and interesting insights in our development for defoamers for high-build water-based systems. Lara, stage is yours.
Thank you a lot, Steffen, for the introduction, and a warm welcome from my side as well. So hello, good afternoon, and good morning to every one of you out there. It's nice to have you here with us. So I would like to continue this session of water-based inspirations by showing you a picture. So what is special about this picture? Firstly, when looking at the image, you clearly see an arrow pointing left. Although, when you look a little closer, there are many smaller arrows pointing right. And regardless the larger number of the right-pointing arrows, the left-pointing arrow stands out. This is in fact a paradox, isn't it? Sometimes we are facing paradox situations and challenges, including the coating industry. For example, protective coatings. In protective coatings, we use water-based systems to protect against water. What's interesting here is that we use something to protect what we want to defend from at the same time. How does it make sense? And how does it work? So that's why I'm now happy to take you to the next step of our journey of water-based inspirations and to even dive a little bit deeper in the world of defoamers. Steffen has already pointed out that the use of a defoamer is of particular importance in water-based formulations. In protective coatings, we are dealing with high-build systems, such as primers, mid-coats, or direct-to-metal coatings. These systems are applied in high film thickness, they are fast-drying, and they are mostly spray-applied by airless technology. And this even enhances the formation of foam, mainly microfoam. So let's take now a closer look at the appearance of a high-build system and zoom in on a coating. As you can see, it's easy to detect all the air entrapments being captured and fixed in the thick and high viscous film. So this entrapped air in the coating will lead to surface defects and therefore to the loss of corrosion resistance. In the protective market, still solvent-borne coatings are dominating, as we are aware that there are several challenges that have to be solved if water-based formulations are used. And one of them is foam. So defects caused by foam make it much more easy for the water to penetrate the coating and to reach the metal surface. This results in the corrosion of the metal and/or in disbonding of the coating. So these processes can be determined by electrochemical impedance spectroscopy. In this test measurement, a glass cylinder is placed on a coated test plate, and filled with an electrolyte, such as sodium chloride solution. This measurement cell is now provided by two electrodes. One is the reference electrode and the other one the working electrode. This test arrangement then is connected to an electric circuit, and a computer with the relevant software records the measurement. At the end of the measurement, you will receive a pair of curves which gives you information about the state of the coating and the internal processes. As a result, the electrochemical impedance spectroscopy provides information about the electrical resistance of a coating. So this diagram shows now the results of the electrochemical impedance spectroscopy of different samples. The impedance was measured at a frequency of 0.1 Hertz. And the higher the value of the impedance, the higher is the electrical resistance of the coating, and therefore the higher the corrosion resistance of the coating. So the sample without any defoamer has lots of surface defects, as it is quite easy for the sodium chloride solution to penetrate into the pores and voids of the coating. Therefore, both, so the initial resistance, but also the resistance after 4 days is quite low, which indicates worse anti-corrosion properties. By using a defoamer, the air entrapments are released, and therefore the water uptake is minimized. The electrical resistance is for that reason much higher, even after 4 days of exposure. BYK 7089 is the first defoamer which has been especially developed for water-based and airless spray-applied high-build systems. And by using this new developed defoamer, the electrical resistance of the coating is improved in a significant way. And therefore, BYK 7089 provides a considerable contribution to a long-lasting protection layer and therefore to a sustainable coating. The results of the electrochemical impedance spectroscopy match the results obtained by conventional corrosion test methods, such as neutral salt spray test. Here, the sample without defoamer and also a standard defoamer show blistering and also some rust dots on the surface of the coating, whereas BYK 7089 defoams perfectly and therefore really improves the corrosion resistance of the coating. So these results show the specific need of a defoamer that is able to defoam or to release the foam in coatings that are applied in thick layers. The defoaming effect is also visible within the coating or at the interface of substrate and coating. In this test, we just spray applied by airless technology the coating on a test plate. And so the film thickness was about, let's say, 300 microns wet, more or less. And after some flash-off time and also some curing or drying time in the oven, the coating was removed again by a knife. By doing so, the protection layer on the substrate can be evaluated directly. And the sample with BYK 7089 hardly shows any entrapped air bubbles, and therefore BYK 7089 gives a perfect protection of the substrate. In protective systems, we normally use multi-layer systems, and therefore the recoatability plays a very important role. Usually, silicone-based products, such as defoamers, but also surface additives, for example, they tend to lower the intercoat adhesion. And the intercoat adhesion can be easily checked with a pull-off test. In the pull-off test, metal dollies are bonded directly on the coated test plate by using a very strong adhesive. This construction then is subjected to a tensile strength, the pull-off, and the force required to break the coating bond is measured. So the use of a standard silicone defoamer, in this case, really lowers the intercoat adhesion. And the intercoat adhesion was tested in an epoxy midcoat to a zinc rich primer, as well as to an acrylate top coat. And we incorporated the silicone defoamers at a relatively high dosage of 0.8% in the epoxy midcoat. And as you can see, although BYK 7089 is also based on silicon technology, it does not show any negative impact on the intercoat adhesion. So this is where I would like to introduce you BYK 7089 as a perfect balancer which solves our challenges in water-based protective coatings. So BYK 7089 is a 100% silicon-based defoamer with an excellent balance between defoaming properties on the one hand and a high compatibility in the system on the other hand. So this is really the defoamer which is used to get rid of foam in water-based primers, midcoats, and direct-to-metal coatings. And therefore, we really need this defoamer to improve the corrosion resistance in protective coatings. So nowadays, the binder technology developed, and it's even accepted by high atmospheric corrosivity classes. For instance, since April 2017, all the coatings for the freight container market have been changed from solvent-borne systems to water-based systems. And this example tells us that even for marine and heavy-duty application, water-based coatings turn to be more and more important. So coming back to the beginning, yes, using water-based systems to protect against water seems contradictory at first. However, water-based coatings already have the same performance level as solvent-borne protective coatings, offering the formulator to the opportunity to gain the solvent-borne performance level while also meeting environmental goals. So the time has come, also in protective coatings, to change their direction and take the path in a greener and more sustainable future. Of course, the development and also the use of great water-based products does not only have taken place in the recent time. So by far, this is no news. We at BYK already started to develop water-based products more than 30 years ago. And to be more exact, it started in the year 1990 with the development of the first aqueous wetting and dispersing additive called dispersive 190. I assume a lot of you may know this product. Since then, we constantly continued to develop water-based products. And now, today, we are proud to be able to offer more than 250 additives for water-based systems. So as a conclusion of this session, I think an excellent statement is that the change to water-based systems has already happened. Thank you. Mark, I'll pass it along to you.
Thank you very much. Thanks a lot, Lara. Please stay on stage.
Yes.
I said it before, the Q&A section is really, really on fire. Thank you very much for asking so many questions. This time I took a lot of more questions, and I would like to ask back Steffen and Markus here up on stage so we could start with that little Q&A session. And I already have the first question for Markus.
Okay.
It is like, does the Newtonian flow behavior lead to settlement of the pigments after storage?
Yeah. So with organic pigments, let's say, we have no problems. There, the Newtonian flow behavior is not a big issue. And but even with very, let's say, heavy pigments, inorganic pigments, iron oxides, even the Dispersive 2018, 2019 cannot overcome physical rules. So these pigments can settle down. Therefore, you can use rheological additives like Optigel WX, for example, to adjust a slightly pseudoplastic flow behavior. And then you are on the safe side. Then these pigment concentrates are very stable. So for inorganic pigments, no need. Newtonian flow behavior is good. For inorganic pigments, you need a little bit pseudoplastic flow behavior.
Perfect, thank you very much. Steffen, the next one is up for you. At what point should BYK 092 be incorporated into the system?
Okay, I think it is meant like at what point of the production process in terms of time, I would guess. So as you might remember from my presentation, I've shown you that it has a broad applicability to different shear forces. So in a lot of systems, it can either be applied at the beginning of the process, in the middle, or even at the end of the process. While, of course, you need, if you add it at the end, some steering time afterwards to get proper incorporation. So you can actually, you're relatively free to choose where you incorporate it as long as you have some shear forces to get it properly emulsified.
So many questions. I have so many cards with me over here. Lara, the first one for you.
Yeah.
Beside epoxy systems, can be used for other systems as well.
Yes. So actually, the BYK 7089 was initially developed, yes, for high build epoxy systems. So as I mentioned in the last sentences, so for example, the change in the freight container market, for example, but it also shows perfect defoaming properties in other systems. So for example, in direct-to-metal coatings, which are also based on different chemistries, for example, non-acrylate chemistry or also polyurethanes. So this is also working in that case, yes.
Thanks, Lara. Markus, ready for another one?
Oh, yes.
Yeah, let's go for it. Up to which pH value can you use Dispersive 2018?
Yes. I mentioned it during the presentation that you can use Dispersive, especially Dispersive 2018, in silicate paints or in water-based epoxies. Water-based epoxies, grinding in the amine part, I think, is not a big topic. So here we are talking about pH values of 10, 11, something like that. So here you can use it without any trouble. Good long-term stability is given. In silicate paints, we are talking about much higher pH values, so sometimes up to 13. Here it depends a little bit on the used water glass, so on the silicate binder, as well as on the stabilizer. But in our standard formulations, we evaluated, we saw very good results, so very good viscosity reduction with this BYK 2018 in the grinding of titanium dioxide and the fillers, and a good long-term stability. But as mentioned, as you know, always, it depends a little bit on the formulation.
Thank you very much. Steffen, the second one to you. Can the defoamer also be used in the mill base?
Yeah, actually, I can give you a short answer to yes. Yes, it can be used in the mill base as far as we've seen it in our lab. Of course, you should always try it in your particular system, but we didn't see any issues here.
Perfect. Let me switch over to Lara again. What is special about this BYK 1789 product?
What is special about that? Yeah, I think there are lots of properties which makes it special. So as I said, firstly, it's really the nice balance between defoaming properties and good compatibility in the system. So usually we just have defoamers that are able to defoam, but then they show also incompatibilities. For example, they cause cratering, or they are not sufficient enough, and for that reason they do not defoam properly. So BYK 1789 really has this quite good balance between, and it's also shear stable. That's why we developed it for airless application. So it can be also used as a grinding defoamer, which therefore is another applicability for this defoamer. And what we also observed, and what I maybe didn't mention during the presentation, is the improved substrate wetting. So it also has a positive impact on the substrate wetting. So all in all, I think lots of benefits in one product.
That's special about it. Perfectly. Markus, another one for you. What about the handling of disper books, especially at lower temperatures?
Okay, the handling, yeah, I think this goes in the direction in the production, when you use it really in the production, and especially some highly polymeric dispersants then shows very high viscosities, especially at low temperatures. So with this Disperbook 2018, 2019, we have really relatively low viscous product, and even at lower temperatures, it is pumpable, so easy handling in the production, no high viscosities that you get trouble with a pumpable wetting and dispersing additive. I would say, in general, easy handling even at lower temperatures.
Great, thank you very much. Steffen, that's the one for you, I guess. The dosage of BYK 092 is between 0.3 and 0.5% in the presentation. Is this the recommended dosage?
Yeah, I think the recommended dosage of a defoamer is so system dependent that it can't be that narrow. So usually we give a recommendation between 0.05% and 0.8% of the defoamer, but sometimes it goes even up to higher than 1%. So it's really always recommended to do a ladder study in your particular system and also using your particular incorporation conditions.
All right, let's say one more per person. That would be the last one to you, Lara.
Okay.
Why does BYK 1789 not show any negative impact on adhesion, although it is a silicone defoamer?
Okay, yes. So I think we really have to differentiate. Firstly, when we do not use any defoamer at all, so we will incorporate for that reason a lot of air, and especially in the airless application, we normally have to avoid the microfoam inside. And if you have all these air bubbles inside, you will also have the air bubbles at the interface of the substrate and the coating. And therefore, this will be the area of no adhesion. So for that reason, also without any defoamer, you will have issues with the adhesion. But if you use a silicon-based defoamer, this not always means that it really lowers the intercoat adhesion, because this is also related to the design of the polymer. For example, what kind of molecular weight is used, what are the side chains, and so on. So this really plays an important role. And we have to say that also silicon-based products may improve the wetting. And for that reason, the adhesion can be, or it's possible that you don't impact the adhesion, and that was in the major focus in the development of BYK 7089. Yes.
Thank you very much. The last one's for you two.
Okay.
Firstly, to Markus. Which pigments were tested in automotive coatings?
Oh, yes. Yeah, I'm not the expert for automotive coatings, but luckily during the preparation of the presentation, I discussed this really deep dive with my colleagues of the automotive department. So they tested especially titanium dioxide, iron oxides, and also bismuth vanadate. So in general, inorganic pigments. And I saw the results, and with all these inorganic pigments, they always achieved very low viscosities, much lower versus a market standard, and a very good long-term stability of these slurries. So in general, for automotive coatings, I would say for all kind of inorganic pigments, Disperbook 2018, 2019 are excellent additives.
Thank you very much. Steffen, the last question for today, for you at least. For future-oriented formulations, it is very important that the raw materials do not contain any biocide. Does BYK 092 contain biocide?
Okay, thank you for the question. I think this question probably comes from the architectural paints, because their biocide-free really is a bigger issue than, for example, for the wood coatings industry. And I forgot to mention that because of my background for the wood coatings. So yes, it is biocide-free, and you can use it for all modern formulations because we designed it to be tailored to modern formulations, right?
Thank you very much. Steffen, Markus, Lara, I would ask for a round of applause, but there's nobody here. So maybe everyone can knock on the,
We
on
will
the tables
applaud
back home.
for ourselves.
Yeah, thank you very much. You are dismissed.
Thank you.
Thanks
Thank
for,
you.
for that wonderful second session. I've said it before, there were so many questions also this time. No question remains unanswered. There is a whole team just there for you, and they will answer your questions ASAP. But please keep on filling those Q&A questions. We're going to take it right here on stage.